The topic for Lesson 4.2 is transformations on the coordinate plane. You'll learn how to transform figures by using reflections, translations, dilations, and rotations, and to transform figures on a coordinate plane by using reflections, translations, dilations, and rotations. How are transformations used in computer graphics? Computer programs can create movements that mimic real-life situations. A new CD-ROM-based flight simulator replicates an actual flight experience so closely that the U.S. Navy is using it for all of their student aviators. The movements of the on-screen graphics are accomplished by using mathematical transformation. Transformations are movements of geometric figures. The pre-image is the position of the figure before the transformation, and the image is the position of the figure after the transformation. A reflection is a figure flipped over a line. A dilation is a figure enlarged or reduced. A translation happens as a figure is slid in any direction, and a rotation is a figure turned around a point. Example 1a asks us to identify the transformation as a reflection, translation, dilation, or rotation. This figure has been increased in size, so it is a dilation. In 1b, the figure has been moved, so our shifted horizontally to the right would make it a translation. The figure in 1c has been turned around a point, so that is a rotation. And in part D, the figure has been flipped over a line, so that is a reflection. Next, we're going to look at all of the rules for reflections, translations, dilations that we can apply to ordered pairs to make them happen. If we would like to reflect over the x-axis, we're going to multiply the y-coordinate by -1, so this is the rule you need to write down. To reflect over the y-axis, multiply the x-coordinate by -1, and they show it graphically there as well. To translate a point a units to the right, we're going to add a to the x-coordinate, or b units up, we're going to add b to the y-coordinate. Now, looking at their diagram, they've actually moved their point to the left and down, so they would have a negative value for both a and b. To dilate a figure by a scale factor k, multiply both coordinates by k. If k is greater than 1, the figure is enlarged. If k is between 0 and 1, the figure is reduced. To rotate a figure 90 degrees counterclockwise about the origin, switch the coordinates of each point and then multiply the new first coordinate by -1. To rotate 180 degrees about the origin, multiply both coordinates of each point by -1. A trapezoid has vertices at -1, 4, 4, 4, 4, 1, and -3, 1. The trapezoid is reflected over the y-axis. Find the coordinates of the vertices of the image. And the rule they gave us to reflect over the y-axis is to multiply each x-coordinate by -1. So instead of -1, 4, w prime will be +1, 4. Instead of 4, 4, x prime will be -4, 4. Instead of 4, 1, -4, 1. And instead of -3, 1, +3, 1. And then they'd like us to graph our original trapezoid, wxyz, and its image, w prime, x prime, y prime, z prime. We've plotted the points at -1, 4, 4, 4, 4, 1, and -3, 1 for our pre-image. And now the image, w prime, is at 1, 4, x prime is at -4, 4, y prime is at -4, 1, and z prime is at 3, 1. And I just threw in that term vertices, and I thought I'd stick this in here as a reminder. The vertices of a polygon are the endpoints of the angles. Triangle ABC has vertices at -2, 1, 2, 4, and 1, 1. Find the coordinates of the vertices of the image if it is translated 3 units to the right and 5 units down. So to find our new A, -2 plus 3 would be 1. 1 minus 5 would be -4. Our new B, 2 plus 3 is 5, and 4 minus 5 is negative 1. And our new c, 1 plus 3 is 4, and 1 minus 5 is negative 4. And of course, they'd like us to graph the original triangle and its image. A was at negative 2, 1, B is at positive 2, 4, and C was at 1, 1. A prime is now at 1, negative 4, B prime is at 5, negative 1, and our new C is at 4, negative 4. A trapezoid has vertices at negative 1, 2, 2, 1, 2, negative 1, and negative 1, negative 2. Find the coordinates of the dilated trapezoid, E prime, F prime, G prime, H prime, if the scale factor is 2. All we have to do a dilation is take each coordinate and multiply it by 2. So E prime will be negative 2, 4. F prime, 4, 2. G prime, 4, negative 2. And H prime, negative 2, negative 4. And of course, we should graph the preimage and its image. E is at negative 1, 2. F is at 2, 1. G is at 2, negative 1. And H is at negative 1, negative 2. E prime is at negative 2, 4. F prime is at 4, 2. G prime is at 4, negative 2. H prime is at negative 2, negative 4. Triangle ABC has vertices at 1, negative 3, 3, 1, and 5, negative 2. Find the coordinates of the image of triangle ABC after it is rotated 180 degrees about the origin. Nice trick. Rotating around the origin, all we have to do is multiply both of our coordinates by negative 1. So A prime will now be at negative 1, positive 3. B prime, negative 3, negative 1. And C prime, negative 5, positive 2. And we got to wrap it up by graphing. And we're plotting points. So my original A was at 1, negative 3. B was at 3, 1. And C was at 5, negative 2. Now that I have rotated 180 degrees around the origin, my new A is at negative 1, 3. My new B is at negative 3, negative 1. And my new C is located at negative 5, 2. In this lesson on transformations, we had special rules to make a reflection, a translation, a dilation, or a rotation.